Hey guys, in this video I'm going to show you how to do a couple more limit problems. So for these we have the limit as x is approaching 0 of x squared minus 8 over x minus 2. We also have the limit as x is approaching 3 of 3 cubed minus 8 over x minus 2. Sorry, that was x cubed. And then this is very similar to the problems that we worked with before of the limit as x is approaching 2 of x squared minus 4 over x minus 2 and the limit as x is approaching 2 of x cubed minus 8 over x minus 2. The first one that we're going to look at is this problem. So for limits, there's a couple different ways that we can solve. One of them is through methods of algebra. One of them is through graphing. One of them is through using our calculator and finding points that get closer and closer to whatever value we're working with. But what I want you guys to see for this problem is that if I plug in 0 into this equation, my denominator is still defined. So this problem, it's not a great idea to sit there for problems like this and try to do all of the algebra behind it. Obviously, we did the algebra before in the last problem, but if you're going to sit there and try to factor this and say it's a more difficult problem than this, and you could have just done direct substitution the whole time, you want to make sure that you are checking if direct substitution is a valid method before the problem, before you go do a bunch of work trying to solve it. So we can just plug in 0 into this equation, so then we would have the limit as x is approaching 0 of 0 squared minus 8 over 0 minus 2. This is negative 8 over negative 2, which is equal to 4. So this is how you would solve the limit for this problem. Again, always double check to see if direct substitution is a valid method that you guys can use to solve these problems instead of sitting there and doing a bunch of work and then getting to the same answer that you could have gotten to just by using direct substitution, because it's a much quicker method. And then let's double check this by using this equation that we got here from the last problem, because from the last problem we got that. But knowing that when we have the limit as x is approaching 0, in the numerator we would have x minus 2 over x squared plus 2x plus 4 divided by x minus 2. And let me double check if this is correct from the equation we had before. Exactly. So then this would cancel out. So then we would have the limit as x is approaching 0 of 0 squared plus 2 times 0 plus 4, which is also equal to 4. So as you can see, if you did go about the longer method for this problem, you do end up with the same exact answer. The answer for this problem ends up being 4, but the direct substitution method was a lot quicker. And now let's try out this problem down here. So again, looking at this problem, if you're wondering what the best method is to solve this problem, I recommend pausing the video and trying to work through this problem yourself first, making sure you get to the right answer, and then going through the steps with me. So if you want to take a second to pause the video, I recommend doing that now. Or if you want to see everything worked out, I'll go through it really quickly. So we have the limit as x is approaching 3. If we plug 3 into the denominator of this function, we still get a defined function because 3 minus 2 is not equal to 0. So we're not going to have 0 in our denominator. So that means 3 is in the domain of the function because it's a valid x. It is a x value that is valid to plug in. It gives us a valid answer. So we're going to have the limit as x is approaching 3 of 3 cubed minus 8 over 3 minus 2. And this is equal to, well, what's 3 cubed? So what's 3 times 3 times 3 minus 8? 3 minus 2 is 1. So 3 times 3 is 9. 9 times 3 is 27. So we have 27 minus 8 over 1. So then we end up with 19 as our answer. Again, you can use the method of factoring and going through all of that extra work for it, but at the end, we end up getting the same exact answer through direct substitution that we would have if we did the factoring of this problem. So these are some easy ways to solve the problem. This method is just direct substitution. Make sure you're paying attention to whether or not your a value can be plugged into whatever formula you're looking at.